going.
All right. Hey, it's Mr. Leatherwood.
And Miss Castella.
And we're going to teach you a little algebra.
Whee!
And we're going to use models. Can you see my hands?
Yeah.
Okay.
You're going to make fun of me again for my voice.
That's okay.
Yeah.
So first thing I want to tell you, can you see this little guy?
Yep.
Okay. This is going to equal x.
Beautiful.
And then these little guys are going to equal...
Wait.
Oh, sorry. You're all kinds of crooked.
Yeah,
what are you
I know.
doing?
Well, I was
You
showing
trying to
them.
make people sick?
No.
Oh,
I was
okay.
showing them our little stash over there.
So this is going to equal 1.
Okay.
All right. So we're good so far. Now you're going to find that with algebra, everything, or with math in general, we need to make things balanced.
Like a
And so-
scale.
Like a scale. And so here's my little scale. Doo-doo-doo-doo-doo. So on one side we have 3 of these guys. So I would say 3x. Can you see that?
Yeah.
Okay. And then we have plus. Looks like we have 6 little yellow guys.
Mm-hmm. So we have 3 X's and 6 ones.
Mm-hmm. And then in here, that's going to be our equal sign. And then it looks like we have 3 times 5, 15.
Yep. 15 ones.
Equals 15 ones. And so what we're going to do today is show you how to use this particular model in order to solve what x would equal.
Yep.
All right. What we need to do is start taking stuff away. Ideally, we want to see how much, we want to get x all by itself. And so I think the first thing I would do is maybe get rid of these 6 units. And so I'm going to take away 6 things. I'll just do that. And if I was to do it number-wise, I would take away 6 things. But if I do it on one side, remember we're talking about a scale, we want to keep it balanced the whole time. I have to take away 6 things on the other side. So now we're even. We took away 6 on this side and 6 on this side.
Mm-hmm.
Everybody good there? So that leaves us with these cancel out. So now we just have...
Because now there's 0 there.
Right.
So it's like having nothing.
Right. So we end up having 3x equals, and then we did 15 minus 6, which leaves
9.
Okay, so if we wanted to, we could write it up here. Can you see that high?
Yeah.
Okay. All right. So now the problem comes is we can't really take away stuff. But I notice I have 3 x's, and I think I could divide by 3, right?
Yeah.
Could divide by 3, and I would get 1x. And if I divide these into 3 equal groups, I could do that also.
Right, because you want each X to have an equal amount of ones.
Mm-hmm. So if I divide...
It's like handing out candy. Each person should get the same amount.
That's right. So if I divide by 3 on this side, I also have to divide by 3 on this side, which gives me 1x, right? So if I divide by 3, it leaves me with 1x. And then if I divide these into 3, each group is going to have 3 in it.
Yep.
So x would equal 3.
Yes.
Okay.
Great.
So this is called inverse operations, right? Whatever we're doing here, we're adding 6. We do the inverse operation to get rid of it. We subtract. Should we show them one more?
Sure.
All right, pause it.
Yeah.
Oh, we're on. So we have a new sample. So we have 1, 2, 3, 4, 5.
5 X's.
5x. Oh,
Your marker stinks.
maybe because
Oh,
there's
because the
stuff.
sanitizer.
Yeah. Plus 3 equals 1, 2x. Oh, geez. 1, 2, 3, 4, 5, 6, 7, 8,
Should be
9, 10,
15.
11, 12, 13, 14, 15. Plus 15. All right.
Okay.
So we're going to
Balance it out.
start balancing it out. I don't know. Where do you want to start?
Let's take away 3.
Take away 3. So we're going to take away 3 over here, but we have to do it on the other side to even it out. So I'm going to take away 3. I'm going to take away 3. So that leaves us with just with 5x over here. And it leaves us with
That was so weird.
2x plus, what do we have? 12?
Yeah.
12. All right, now what do you want to do?
Now let's take away 2X.
Okay, because we're trying to get everything by itself. So let's get rid of 2x. So minus 2x over here, but we also have to do it over here. So I'm going to take away these two. I'm also going to take away these. So now
comes the separating part.
that's right. I have 3x equals 12. So now I've done all the addition and subtraction that I can do. Now I need to do either multiplication or division. In this case, I'm going to divide because I have 3. So I'm going to divide by 3. And I also have to divide it by 3 over here. So if I divide this into 3 equal groups, I'm going to end up getting 4 in each group, meaning 1x equals 4 individual things. And if it helps you, you can kind of scoot these off to the side.
So one person should get 4 pieces of candy.
So x is going to end up being 4. Okay. I wanted to notice that when we're canceling these out, we're actually going backwards from our order of operations. So instead of doing multiplication and division first, we do our addition and subtraction first, and then end up doing our multiplication division. So this is just a model, one model that you can use to show you, or to kind of make a point of, it has to be balanced on both sides.
Showing you the picture.
Yeah, definitely. All right, let's do a little number. Okay, so continuing to solve equations, but
Without the picture.
without the pictures. So you had one, what was it?
Let's do 3x plus 1.
Okay. Okay.
Is equal to x minus 11.
Okay. So remember, everything has to be balanced. So we're going to start getting rid of stuff. So yeah.
Okay.
Would you get rid of the 1 first?
I would get rid of the 11 first.
Would
but
you?
You can get rid
No,
of
that's fine.
I
So
like to add better than
okay.
subtract.
So it's x minus 11. So we're going to do the inverse operation. So we're going to add 11. But we have to make sure that we do it to both sides.
Got to be fair to your equation.
And so that would give me 3x plus 12. These these cancel out, so it just leaves x on the other side.
Yep.
Okay. So now what would you do?
Now we have to move the 3x over to make it balanced and to get rid of it, so we have to subtract 3x.
Okay.
And once you do it to one side, you got to do it to the other.
Okay.
So, and that x right there, it has kind of an imaginary 1 in front of it, so it's really 1x minus 3x. So if we did 1x minus 3x, we would get
negative 2x.
negative 2x. And then you would bring down your positive 12.
And then these just cancel out too, right?
Yeah.
Okay. So then we have a positive 12 or just 12. You could just write 12. And we have negative 2x. So now is when we need to divide it into groups, right?
Yep.
So we're going to divide by negative 2 and divide by negative 2. And go ahead.
So x is equal to, and you got to remember, positive 12 divided by negative 2 is going to give us a negative answer. So x is equal to negative 6.
Okay. All right. So very similar to the model. Yeah? Kind of, sort of?
Yeah.
Okay.
Just more mathematical
Mathematical.
instead of pictorial.
Okay. One more?
Yeah.
Okay.
You could make it up this time.
I can make it up this time?
Pressure's on. Can't look at the book.
I can't look at the book?
Nope.
Oh, that's not cool because I already looked at the book. 3x plus 2 equals 14.
Okay.
Okay. Yeah. So 3x plus 2 equals 14.
Yep.
I want to get rid of the 2 first.
Yep, because there's no other x's, so we can't combine anything.
So that would equal 3x, but I have to do it on the other side also to keep things balanced. 14 minus 2 is 12. So then we have 3x, or 3 times x equals 12. So I want to divide by 3. And these are going to cancel out or turn into 1. And so that leaves x equals 12 divided by 3. 4. All right, so we looked at a model, now we're looking at just the numbers. Ta-da!
Hope you liked it.
Me too. Hope you enjoy it. A lot of y'all have been doing really good in the algebra part.
Y'all love it.
Yeah. All right, see ya.
Bye.